Now it's time to start a discussion about polymorphism. Polymorphism is a fundamental concept in object-oriented programming. The word polymorphism is derived from Greek, meaning many shapes or many forms. Poly means many, morphism means forms. In programming, polymorphism allows objects of different classes to be treated as objects of a common superclass. More importantly, it allows methods to do different things based on the object it is acting upon, even if they share the same name. And there are two types of polymorphism: method overriding, runtime polymorphism, when a subclass provides a specific implementation for a method that is already defined in its superclass, in its base class or its parent class; and method overloading, compile time polymorphism. The Python does not support method overloading in the traditional sense like in Java, C++, or Kotlin, but similar behavior can be achieved using default arguments or variable length arguments. And let's look at an example of polymorphism. Let's say that we have a class called animal. It's going to have a function called sound, and it's going to print animals have different sounds. Let's remove this. Let's go down here. Let's create another class dog is gonna inherit animal. We're gonna have a def sound, and it's gonna print the dog barks. And the class cat or cat, and it's gonna inherit from animal. It's gonna have a def sound self, and it's gonna print f the cat mouse. So in this example, we have a parent class animal, which defines a method sound, and child classes dog and cat override the sound method to provide their own specific implementation. So we have the same method, but with many different implementation, or in other words, we have the same method with many forms. So this form and with this form. Okay. Let's create, so we can use a single function to operate on different types of objects thanks to polymorphism. Let's see how this works with the following code. So I'm gonna go down here. I will define an animal underscore sound function. I'm gonna have an animal parameter. I'm gonna say animal dot sound. Then I'm gonna create a dog instance. Dog equals dog, and cat equals cat. Then I'll type animal sound dog and animal sound cat. Now if I run this, get the dog barks, then the cat meows. So we have a class animal with a method sound up. Then the dog class inherits from the animal and overrides the sound method to print the dog barks. The cat class also inherits from animal and overrides the sound method to print the cat meows. The polymorphic function animal sound takes a parameter animal. The parameter animal is expected to be an object that has a sound method. When animal.sound is called inside the function, Python determines, and this is very important, Python determines at runtime which class the animal object belongs to and calls the corresponding sound method. The animal sound calls the sound method to the dog class, to the instance dog. The output is the dog barks, and the animal sound cat calls the sound method of the cat class instance cat, and the output is the cat mouse. Let's see polymorphism with built-in functions. So I'm gonna bring some code and I'm gonna explain the code. So let's delete this and I'm gonna bring this code. Now the len function is polymorphic because it can take different types of objects, strings, lists, dictionaries, etc., and can return the length of the object. Python dynamically determines the type of object and applies the appropriate logic to compute the length. And can also have polymorphic behavior with abstract classes. And for that I'm going to bring some code and I'm going to explain the code because it will take some time to type all of this code. And we have here shapes. We can take all of this and put it here directly. Let's delete this. So we have from abstract, import abstract and abstract method. We have an abstract class with the abstract method, and we have also here another abstract method. We have pass, so we don't provide implementation, and then we have rectangle and circle. And let's explain the code. So we have first at the top we have the abstract based class shape. The shape class is an abstract class defined using the ABC module, and it has two abstract methods, area and perimeter. Any class inherited from shape must provide implementation for these abstract methods. The concrete class rectangle and circle inherit from shape and provide specific implementation of the area and perimeter methods. These classes cannot be instantiated without implementing the abstract methods. The polymorphic behavior. We create instances of the rectangle and circle and store them in a list named shapes. We didn't do that because I put the list directly here. Then we iterate through the list and call the area and perimeter methods. Due to polymorphism, Python determines the appropriate method to call for each object. For rectangle, it computes and prints the area of the perimeter based on its implementation. And for circle, it computes and prints the area and the perimeter based on its implementation. Now, let me show you a more practical example using polymorphism. So let's delete all of this code. And let's consider a more practical example of polymorphism. Imagine you have a payment processing system that can handle different payment methods, such as credit card, debit card, or PayPal. I'm going to paste the code and I'm going to explain the code. So, first we have the base class payment processor. The payment processor class defines a generic payment method which raises an extension if it's not overridden by subclasses. Subclasses credit card, debit card, and PayPal. Each subclass overrides the pay method with its specific implementation, defining how each payment method processes a payment. The polymorphic function process payment takes any object that is a subclass of payment processor and calls the pay method. The correct implementation is determined at runtime based on the object passed. And the real-world application in this example is a real-world scenario where polymorphism simplifies the process of handling multiple payment types. If a new payment method, cryptocurrency, is added, it can easily inherit from the payment processor and implement its own payment method without changing existing code. So why use polymorphism? It simplifies code. It allows you to write code that works with objects of different types and classes. Extensibility. It makes it easy to add new functionality without changing the existing code base. Maintainability. It leads to more maintainable and modular code. Interface standardization. All objects that implement a particular method or interface behave in a consistent way, reducing bugs and making the code easier to understand. Alright, this is our discussion about polymorphism. I'm gonna end this video here and I will see you in the next video.